Okay, so here we have a improper integral. We have to identify if this is convergent, divergent, and if it's convergent, we need to find the value for the area. So let's see what this is. So we have an infinite bound of integration, and another thing that we can potentially have is if the denominator is equal to 0, which is gonna be a number that's the denominator is gonna be 0 when we have -1 is equal to x. But that's not within this, so we don't have to worry about that. That's not going to be our vertical asymptote. We don't have to worry about that. And so we're only going to be worrying about this, which is going to be a potentially infinite area because we have an infinite bound of integration, making this an improper integral. So let's evaluate. So let's do the limit as b approaches to infinity, integral b0 x squared by root 1 plus x cubed dx. So these problems can be quite time consuming, but it's always important to show all your steps so you don't make any stupid mistakes that can cost you the whole problem. So the first thing I want to do is find the antiderivative of this function. So the denominator, I'll set this equal to u because I can see that that's going to be quite easily just 3x squared, which is du, so 3x squared, since this is 0. Review differentiation rules if you forget them at any point, but it's very important to know them. We don't have a 3 here, so we can always insert a 3, but we have to get rid of that 3 because it's going to change our value if we don't get a 1, if we don't put in a 1/3. So this is just the limit as b approaches infinity. It's 1/3 integral b becomes 1 plus b cubed, right? And so that's just 1 plus b cubed. 0 is just 1. And then 3x squared dx is du. And then this just becomes 1 over root u. Sorry, 1 over root u. I was confused for a second. And then this is du. Okay, so this just becomes, let's simplify this to make this look a little better. So this is, I'm going to write it up here, is equal to the limit as b approaches infinity. It's 1/3. And then this is equal to, so I'm writing every single step here just to make sure I don't make any mistakes. So 1 plus b cubed, so this is 1. And then this just becomes u to the -1/2. We always like exponents when we're doing integration, right? There we go. And even differentiation, really. So this is equal to the limit as b approaches to infinity. So it's 1/3. What's the derivative of this? Well, the antiderivative of this. Well, u to the -1/2. So u to the -1/2 du. This is just equal to u to the -1/2 plus 1 by -1/2 plus 1. This is equal to u, -1/2 plus 1 is 1/2 by 1/2, which is times 2. Right, same thing by 1/2, which is multiplied by 2. Let me write that there. So this is over multiplied by 2 root u, plugging in 1 plus b cubed, and just 1. Okay, so this is equal to the limit, that was a bad L, limit as b approaches to infinity. So this is 1/3 times 2 root 1 plus b cubed, and then minus 2 root 1, it's just 2. This is equal to the limit as b does approach to infinity, and then this is 2/3 root 1 plus b cubed minus 2/3. Okay. This just becomes the limit as b approaches to infinity. 2/3 we can push out, and then this is just root 1 plus b cubed minus limit b approaches to infinity 2/3. This is equal to, well, this is minus 2/3, and this, so this is 2/3, times something. So 1 plus b cubed as b approaches infinity. Infinity cubed is infinity, plus 1 is infinity, and then when we root that, it's still going to be infinity, so this is actually just infinity. So this is interesting because we have 2/3 times infinity, that's still infinity, minus 2/3, still infinity. This is interesting, right? So this is going to be a divergent, right? Diverges. This diverges. Okay. And that is our conclusion. So all this work to identify if this function diverges or not, or converges, and it diverges, and this is all our work for that. I hope you found this video helpful.